Today we will talk about a common problem in code. We call it conditional complexity. It happens when code has too many if statements, switch statements, or nested conditions. This makes the code hard to read and change. In the beginning, when you create your code, you use if and else, and it's a simple condition. But we write a few rules and everything looks fine. But with the progress of our project, we add more rules. The code becomes more and more complex, like these railway tracks. It's hard to see where the logic goes, and small changes can cause big problems. That's what we call conditional complexity, when our logic grows and becomes hard to follow. And when you see the code with some conditions and you understand that you need to refactor it, first of all, the first step maybe decompose conditional. I shown you it's in a previous lesson. I hope you remember that decompose condition means that we separate our if condition into several methods. One method for condition, one method for then part, and one method for else part. This makes the code easier to read and understand. Instead of reading a long if statement, we can read simple function names that explain the logic. But sometimes it's not enough. Here you can see the example. This is a code with several if condition, and here I have some little duplication of code. How do you think? How we can fix and remove this little duplication? You can tell. Yes, you are absolutely right. It's very simple. We can sorry, the quality of your microphone not so good. Yes, we can combine all if condition into one long condition, but it's very important to move this long condition into special method and create the understandable name for this method to make it more readable. In such case, we can remove the duplication of control code here and make it easier to understand. Yes, I hope you understand that it's very easy way of refactoring, but we can use it, and this way of refactoring in literature has the name consolidate conditional expression. But please, when you do it, don't forget to create new method and with understandable naming. So the next example here, again, I have little duplication of code, and I hope that you have ideas how we can improve this code. Please tell me. Here we have duplication here and here in. Yes, you're absolutely right. It's very simple, but it's refactoring too. We can move our send method outside the condition and use it. And in literature, this way of refactoring has a special name, consolidate duplicate conditional fragments. It's very simple, and I hope that you already use this technique when you create your code. The next little example of conditional complexity. Here we have some complex for understanding some complex code. It's hard to understand when we will go out from this code, and maybe you know what maybe you know such term as pyramid of doom. Sometimes in our code we can create such structure when we use a lot of nested code, and sometimes we can create it when we use something like callbacks in our code, but sometimes we can create it with very complex if condition, if and else and if else and another variants. We should remove this type of code from our code base because it's very hard to understand this code, it's very hard to change it, and I think sometimes we can find the errors inside this code, some bugs or something else. That's why we need to remove it, and animation again. This slide. So we need to rewrite this piece of code, and this way of refactoring we call replace nested conditional with guard clauses. If your language has some elements like guard, it's better to use it. For example, in Swift we have such word in our language. But if it's not, you can rewrite your complex condition if you will try to write it in such a way in which you will return in the first line. Like here, we understand that if this condition will be true, we will return and go out of this condition. And it's better to create such condition when you understand how you can move out this condition in the first line, in the second line, and moreover. So in this situation, when we... What? Yes. Yes, it's better because it's not... Yes. Yes, of course. If your modern language has some special words to solve this problem, it's better to use them. But sometimes if we use some old languages like Java, we have not anywhere, and so it's better to separate our nested condition into the list of conditions. In this situation, easier to change something, to add new condition to this list, or just to find the place in where we will go out from this condition. The next example. What is the problem with my keynote? Sorry. Animations again. Not this one. Here I have the example of code in which we can find a very interesting thing. It's a control flag. Here we have the variable with type of boolean with name found. I think that you use sometimes this way how to determine can we go out of for loop or something else. Especially in the first year of university, students like to use this type of control flag. But it's not a good idea because this approach has some problems. For example, we create new variable. It means that we need to remember about it. We have to check this flag many times. It means that our code becomes longer. It's easy to forget to update this flag, and sometimes it can add extra logic that hides the main idea of our code. That's why it's better to remove it, and a lot of books about refactoring recommend us to remove this control flag because we have special words in our languages like break or return. A lot of years ago, programmers used this type of control flags because they had not any break or return words in very old languages. But now we have it, that's why we can use it. And if you if you find the code with control flag in your project, it's better to remove the control flag and use the break or continue or another special words which we have. The next example of conditional complexity. Here I have the class bird, and here I have the switch statement with some cases. And in every case I check the type of my bird. I can have European or African or another bird, and some behavior depends from the type of my bird. Maybe you have an idea how we can remove this switch condition and all conditions and use some another method how to determine the behavior. Yes, you can tell your idea. You can think a little. Yes, but in this case, I think that we can use something more complex, maybe something from object-oriented programming. Yes. Yes, you are absolutely right. Very good, guys. Great job, I think, because you are absolutely right. We can replace our condition with polymorphism. In this situation, when we determine the behavior of some object from the type of this object, we can just create the hierarchy of our birds and implement the behavior inside some methods and just call this method, and behavior will depend from the type of our bird. It's European or African or something else. I think it's time to create the screenshot to check the attendance because 15 minutes is over. Please wait 1 minute. I need to create it. That's all. Okay, yes, you're absolutely right. The next example, we can use conditional logic sometimes when we have such situation when a class has extra behavior that depends on a condition. For example, if logging is enabled, we should write to log. If we need to send email, we should send email, and another conditions. All this extra logic added on the top of the main action. If we put everything in one class with many if statements, the code becomes hard to read and change. And in this situation, when we use condition logic to add new behavior, we can use special pattern. We call it decorator. I hope that you know what is it. So let me show you the example. Here we have a little class notifier, and inside this class I have the method send and little condition. Of course, it should be more complex and longer, but I have not enough space in this slide. That's why here I have only two if statement. If we want to send email, if send email is true, we should do one thing. If send SMS is true, we add new behavior. It's important. We do another thing. So in every if statement, we add new behavior to our object. That's why here we can use decorator pattern. If you don't remember what is it, I add this image. You can remember maybe or just learn this pattern in the first time. This pattern allows us to add new behavior to some object because we create some complex structure. When we have base object, we put this object into another object, and we can create such maybe a chain of objects, one object inside another, inside another, inside another, and we can call some operation in the one object, and it will call the same operation in the child, and moreover. In our example, we can replace our notifier class with such hierarchy. When we create interface notifier with method send, we create a basic notifier and special notifier, or not notifiers, and decorator for email to add new behavior, SMS decorator to add new behavior with sending SMS. We can add more decorators if we need to add new behavior. And when we want to send some information, we just create such structure. As I told you, we have one object inside another object, inside another object, and just call notifier.send. And it means that we will run the method send inside this object, then inside this object, then inside this object. And we will see all behavior what we want to see, what we want to have. Here we just replace this statement conditional statement with one creation of object and running of one method, and that's all. I think decorator, it's a great pattern. We can combine some structures inside it. The main logic stays simple, and each extra behavior will be in its own class. So let's look at the advantages and disadvantages of the decorator pattern. It's a very powerful tool, but it should be used carefully as usual, because it can make our project more complex than we need. It's great when we need flexibility and want to avoid many if statements. But it's not always the best choice for small or simple cases. If you have only two if statements, it's not necessary to create big decorator pattern. It's too much. In this situation, when you have only 2 or 3 little conditions, maybe it's better to not to do anything. So the next example, when we have if condition, like in this example, and inside this condition we make one thing or another thing, and it depends from the state of our object. I think in mobile development we often do something depending from state of our screen. If we have the data, we should show the data. If we have not, we should show the placeholder, and moreover. And in this situation, we can use another pattern, which we call state. I hope that you remember what is it. If you don't remember, as usual, I will show you the diagram of this pattern. In this pattern, we create basic state of our object and concrete states like loading, maybe on error, maybe has data, maybe something else, and we hide the behavior in some state inside this state, like here or here, and we just when we need some behavior, we just call state.handle, and that's all. We don't need any if conditions. And in our example situation, we can change our code with such hierarchy when we create special concrete states for every state what we need, and when we want to run this behavior, we just run state.claimedBy, for example. And that's all. As usual, advantages and disadvantages, and as usual, the state pattern is powerful when the behavior changes based on state, and the logic is complex. But if the logic is simple, if maybe enough. So in every situation, please choose the right tool for this job. And in this slide, I have the whole list of refactoring methods which we can use when we find the conditional complexity in your project. You can use a lot of methods without patterns, and you can add pattern. For example, in the previous lesson, I already shown you how we can replace conditions with strategy. You can use this method for conditional complexity. In the previous lesson, I shown you it for long method. Here we can use the same method, or maybe decorator, or maybe state. That's all about conditional complexity. In this slide, I repeat the list of code flows for Friday. Usually, I just show all of these code flows by myself, but I think a little, and every of these code flows is little and simple, and I hope that it will be interesting if you try to do it by yourself, to learn it in the books, which I published in Google Classroom, or maybe in the internet. In the internet we can find such information too. You can create some new example or something else. So if you want, you can do this task. It's optional for extra points, and 3 points for every code flow. If you want, you can select more than one, but if some students will not have some code flows, but the student wants to show something, it will be the problem, I think. So before the Friday, please select and create several slides about it. As I shown you, what is it, what is the code flow, how to fix it, why it's a problem, and some example. No more than 3, 4, 5 minutes. I think that's enough. Tomorrow you will have the practice lesson as usual. Very interesting. I have the problem